So it's good to be back at LASCON. I don't have the history of a stellar gentleman and neighbor of mine, Jeff Williams. But I've been in mobile security since that thing we used to all be addicted to called the BlackBerry device. So some of you are old enough to remember that. Some of you are young enough to maybe have never actually owned one. I've had the opportunity to speak a couple times over the past half decade on AppSec and have become more and more active with the OWASP mobile project that's gone through a pretty dramatic update over the past few years. And so I've been traveling the world with Sven and Carlos and a number of other folks involved in the OWASP mobile project, really sharing information on what's going on with the specs, but also general best practices around mobile AppSec. We've also been doing a lot of work training web AppSec people on mobile AppSec skills. So if you don't mind me asking, if show of hands, how many people have mobile experience? How many people want to learn about mobile? Very good. So I'm going to teach you some today and actually show you an asset you can access, which is academy.nowsecure.com. The OWASP mobile project team is going to be sharing it out. You'll see the link here in a minute. It's all free training. So a much deeper version of what I'm about to do you can get online. It's just self-paced. It's not like a compact CBT. It's basically sit and watch a bunch of videos of people who do pen testing all day explaining how to do it. And so with that, I have stickers. If you know about Frida and Radari, so our research teams created them. So if you're into reversing, you may be using Frida and Radari. And false positives suck. It's just a fun sticker. So every conference I have a fistful of these. Feel free to come up and grab one afterwards. So they seem to motivate the world. So I got my start back actually working with Microsoft on something called SQL Server. So you can guess how old I am. I think there's one other gentleman in the room who has a similarly shaded beard as mine. And so over that journey, I hooked up with BlackBerry in the early 2000s and have kind of been in mobile ever since. And I'm actually a gadget guy, so I'm wearing lots of biometric technology too, some of which we've actually tested. So I've got an Oura ring on my finger, which if you've heard of seen one of these, the NBA was using this during COVID, measures your temperature and your health and other stuff. I can't live without my Apple Watch. I also have diabetes, so I'm wearing a device for that as well. Medtronic happens to be one of my customers. So now I am a technologist, but I am not a pen tester. And one of the things that I've learned in my journey is there's a big difference between those two. So while I can pontificate on security architecture, I'll answer the questions of yours that I can, but I'm not a practicing pen tester because those people are way smarter than I am. What I do, however, is I do help build specs and strategies, right? So that's kind of the side where it is. And way back when I was working on SQL Server, I helped write ANSI SQL 89 and ANSI SQL 92. For any of you who have ever done database work and tried to work with 10 large database vendors like elephants in the room, that's kind of what it's like. The good news is that OWASP is a lot more friendly. So we work with lots of companies. My marketing people make me say that. Now Secure has mobile products and solutions. They're really cool, and there's a bunch of free training out there available as well. A lot of organizations use our open source tools or our commercial tools for testing, and feel free to take advantage of those. So I'm going to talk about mobile AppSec and show you some mind-blowing stories. I think Jeff Williams this morning talking about how the average website has like 30 vulnerabilities is true. I will show you the scary stats for mobile you probably never saw. Going with that, I'm going to talk you through the highlight reel of the MASVS and how to think about if you're a web pen tester, what do you need to understand to move your way into mobile. We actually are also working on a second project. So Jeff this morning talked about labeling. Well, the precursor to labeling is software bill of materials. And so there is an OS project that got started late last year. It's called Cyclone DX. It is an SBOM spec. I'm going to touch on that a bit. We're also doing a ton of work around mobile apps connected to IoT. Of which I'm betting some of you have some and others of you are scared of them because they are so insecure. So there's an organization called IOXT, and we actually worked with OWASP to take the MASVS and turn it into a certification program for IoT devices and mobile apps connected to IoT, and I'm going to show you a little bit of that as well. And then there's links to lots of stuff at the tail end here. So I talk fast. There are a ton of slides. On my LinkedIn, I will post a link to the slides. You can also just hit me up over email or any other things. So did you know that in the last 18 months, apps like British Airways and Walgreens and the Mercedes Mini car app And you may have heard about the small Apple problem with iMessage and the NSO 5.0 days and things like that. And so I guarantee you, you have breached or breachable apps on your mobile device, right? Now, that doesn't mean you're going to run out of the room and burn your phone. The reality is, if you're doing web security, you already know they're out there. The question is, how many are they? How bad are they? How severe are they? What's their CVSS score, their exploitability, and all the rest? And so there's this presumed security about mobile in many instances, and it's fascinating. I'll meet with executives in, say, a Fortune 100 company and start talking to them about their security and controls that they have in place for their web perimeter, and they'll be big and investing, and we spend millions of dollars on it and all that stuff. And then I'll say, what are you spending on mobile? And 99.99% of the times they'll be like, I don't know, we don't prioritize it, right? And so that then leads to some interesting conversations that are why so many of these things are actually breached. So we have a tool that scans the Apple App Store and the Google Play Store, and it benchmarks for security and privacy vulnerabilities, about 4 million to 5 million of the apps. Some of them you can't scan with automation for various reasons. The sad news is that 85% of those apps violate one or more of the OWASP Mobile Top 10. 75% of them, 75% of them, I haven't updated it yet, would violate GDPR if somebody chose to look at it from an enforcement perspective. So like many other things we see in web, mobile is not the greatest thing in the world. And I think everybody's aware, there's last session in here about supply chain. I mean, the supply chain vulns are off the charts. We often find, both in our automated testing and our pen testing, that at least half of the vulns in an app are because of supply chain issues, either improperly configured, not necessarily malicious, just really bad stuff. So if you actually want to learn about how bad or good the App Store apps are, there's two resources for you. The one on the left is actually takes our App Store benchmark and abstracts the data so we don't do 1,000 responsible disclosures at once. So you can log in on the left side and see the top couple hundred apps in each of the App Store categories to give you a sense of how good or bad they are. What I will actually tell you is almost all the groups are about the same, which is mediocre. We score apps on a risk scale that's just like you went to school. So 90 to 100 is an A, 80 to 90 is a B, 70 to 80 is a C. As a broad range, the top 5,000 most popular, most used apps in the App Store score about a 68. Just to give you kind of order of magnitude, right? So it's almost 70, so it's almost a C. So the one on the right is actually a breach tracker. One of our enterprising younger employees kind of had built this intranet site that was tracking breaches, and we just turned it on to public so you can see it. So this isn't every breach on the planet. This is if it makes the news, we have a harvester that finds them and adds them to it. So it may or may not be perfectly up to date, but if you're looking for evidence to talk to your peer group or talk to your boss, these things are helpful to kind of help them understand where the mobile risks are. So if you come from the web side of the house, imagine a world where there's no browser controls. Imagine a world where there's no browser sandbox. Imagine a world where the developer has to understand how to do storage securely. Imagine a world where the developer has to write their own cert pinning libraries. The reality is that in the mobile world, it's more complicated than web because your mobile device is a non-trustable asset. And so whereas you might put 90% of your web code behind a firewall and all your layers of protection and just a little bit's coming back and forth in the browser, the reality is that 70, 80, 90% of a mobile app may actually be on the device. And with tools like Frida and Radari, the stickers that I have, I guarantee you I can reverse your app. It doesn't matter how good your anti-tampering is. We can reverse it, right? And so your app's going to go into a hostile environment. Most of the time, developers don't understand that their app is running in a hostile environment. Most of the time, security architects don't understand the app's running in a hostile environment. And that's how we wind up with a lot of attacks occurring on that side of the house. You have any language, you got all that other stuff in place. So you need to think about testing on a real device as well. The first generation testing tools for mobile that weren't manual pen testing tools that were automated were running on emulators. And what actually happens is when your apps go through the App Store approval process with Apple and Google, they actually change them a little bit. And then they wind up going through the app stores and then they're DRM down onto your device. And so what often happens is even if it worked fine in staging, when you get it into prod, its behaviors may be slightly different. And so you want to make sure you're monitoring what's going on in prod as you go through the App Store process as well. And so quick class, right? So I sort of said this, right? You can leak or attack on the device, but a mobile app also typically includes cloud services and the back-end infrastructure. And so while we do mobile application security testing, we don't do web. we make sure that we still look at the back end. We make sure we still look at the network services. Now, that's not the same as you having a full-blown API sec. You should have one of those. If your websites and your mobile apps are using the same back-end APIs, that's awesome, because that means you're already hammering them in another way. So the only thing you really have to pay attention to is the mobile side, because you're already getting it through kind of that Venn diagram of the other types of testing you're doing. Now, we, for years, have been publishing this mobile attack surface. There's a way more complicated version of this on our website, and you don't have to understand all of them, but this is to kind of give you a way to think about framing the problem, right? What's going on in my code? What's going on with data at rest and storage on the device? What's going on with transport and data in motion over the network? What's going on at runtime and the characteristics of runtime on those mobile devices, especially as OS versions change and library dependency changes? And then the back end, obviously, that they're talking to. So when you think about how you're going to go actually attack the attack surface, you want to think about, how am I protecting my code? How am I protecting the data at rest, right? The data in motion and the API back end. Now, what you're going to see when I get into the MASVS is these are a couple of the core areas that MASVS focuses on as part of the strategy. So I'm going to walk you through a highlight reel of the MASVS, but I'm not going to read it to you. It's about that thick if you print it. More importantly, I'm going to tell you the 5 things that matter in the entire book. And I'm going to do that through the lens of where are the most common vulnerabilities found in production. And so if you think about that, right, you want to know where the bad guys go or where the frequent failure patterns are so you can focus your work. And that's where you want to develop your skills and have your pen testing program focus on those certain areas. So jumping over it, here's the project. The interesting thing about the project is when I first got started, the top 10 was kind of the focal point, and the top 10 was very coarse-grained. And so the MASVS is really the Bible to get started, not to be religious, but it's a place to get started. The other great thing is we advise clients, get your architects and your senior development leaders to actually read the MASVS or the crib sheets that are created around the MASVS. It will help them understand the fundamentals of what mobile architecture means from a security perspective, and that will improve their ability to design and build things. The MSTG is the very, very long version of what are all the tests that map to everything in the MASVS. And yes, there is an Excel spreadsheet you can download that has all the line items in it. So the reality is that it's not actually possible, and I haven't seen anybody who's got a testing program that does the entire MSTG. It was an academic approach to model everything you could test, but don't feel bad if you can't test at all. And I'll hit on a few of those things as I go through here. Now, as you would do in a threat model conversation for web infrastructure, you need to think about what kind of app do I have, what data is in it, what IP is in it, what transactions transpire. And so there's an organizing principle here in the MASVS that starts with 4 boxes that I'm going to build. So the first one is basically your basic app. You're probably going to spend a basic amount of time testing it as well, if at all. So let's say I've got the WebMD healthcare app. It's got no PII, no transactions, there's no account, you're just looking up information. If I'm WebMD, I probably care a little bit about people putting bad data up there, but there's no liability because there's no contracted relationship with anyone who uses it. So actually, if you talk to WebMD guys, they don't have any security team, and I could show you the RD we did, and it would make you cry. Level 2 is the apps that matter. Right, so level 2 now, I've got regulated data. So if you're a bank and you're doing financial transactions, you're automatically in L2. If you're a retailer and you have PCI, you're automatically in L2, and so on and so forth. And so like a healthcare weight monitoring app, right? So I have one of those on my thing. I've got one of those Wi-Fi scales at home, and it tracks a bunch of my health data, right? Now you got to care about that health data. So there's certain protections I want to have in place, and therefore there's certain testing strategies. Now, resiliency is something that we don't usually talk about in the web world so much, but is critical in the mobile world, which goes back to the I can reverse almost anything. And so because that binary is running in the wild on a device where it can be attacked, you need to think about resiliency strategies for what can I do both from an application design and architecture side, as well as an app hardening side of the house. And so I'm going to show you some examples of that as we go through it. So maybe I have a medical formulary app. Now the medical formulary app doesn't have PII or patient information in it, but it does have recipes for drugs that if somebody manipulated that, it could kill someone. So you want to make sure that the drug recipes are accurate, right? So I'm going to make it resilient, and I'm going to design it in a way and test it in a way that I can make sure someone can't manipulate the formulary to create a bad drug mix that could kill someone, right? Sorry, I'm on the kill thing. And then this is really where a lot of the more important things, right? So I'm not currently wearing it, but my insulin delivery app that talks to the thing on my body that injects insulin could kill me if somebody did the wrong thing and injected too much insulin, right? So I use the healthcare thing because that usually gets everybody's attention, right? Because it really is kind of life or death world. And we're doing a ton of work with medtech world. You know, COVID has driven an explosion in the medtech side of the house that was kind of coming as rolling thunder. And so I think this finds a fun way to do it. So standard security best practices. Now I need things like hardening against lost device. I need to think about things like cert pinning and multi-factor auth and any other risk controls on the left. Over here, now I need to harden it. So things like device binding, obfuscation, anti-tampering. British Airways, for example, the British Airways app was breached in 2018. You may have seen it on the news. It's about 380,000 records. They used a mobile app to figure out how to attack the back end. And then they went and they attacked the back end. They got the records, passports, credit card information, the whole 9 yards. The interesting follow-up story on that was 18 months later, they were the first GDPR fine in Europe for 180 million pounds. Their share price dropped 32% because of the fine, not just the breach. And so the reality is, you know, that these things kind of matter. And one of the things they've done in their architecture now is they do device binding. So when you download the app, it's actually going to hash not only your account information, but the fingerprint of the device, and it won't run anywhere else. And that helps them with an anti-tampering strategy. So there's lots of things you can do around there. So the MASVS is basically 8 components to it. Some of them are the tests and some of them are the strategy. So be a good threat modeler, right? If you and your team don't have good threat modeling skills, do it. Actually, we're collaborating with the security journey guys and putting together a threat modeling class very specifically for mobile. From that perspective, and they have some speakers here. Data storage, crypto, authentication and session management, network communication, environmental interaction, code quality, resiliency. Now, if you're used to like the API sec list or the web sec list for OWASP, you'll notice a lot of these are different, right? And they're different because of the architectural nature of mobile apps, not because of we felt like making them different. And so what I'm actually going to do is talk to you about where to focus based on where the bad stuff is, right? So this is sort of begin with the end in mind. So we're going to start with data stored in an insecure location. This is the worst offense we find in virtually every application. When you benchmark the app stores, about 50% of all apps in the app stores that we analyze have insecure data storage in some way, shape, or form. As a general rule, developers are used to having control of the asset where the data is stored, because they're used to having a firewall or a server or something behind it, right? Well, that doesn't happen on the device, so you need to understand that. So inside of the MASVS, there's 2 areas to focus, which is data storage, privacy, and crypto. On each of these slides, you're gonna see tons of links. So these are links to the repo details, so the Git repo details in V2 and V3. There are also links to Apple and Google documentation as well. Strongly recommend that if you're going down this path, read the Apple and Google documentation. It's actually getting to be quite good in terms of its own training ability to help you understand. The other thing about it is it's written for developers. So the asset you can give to the developer is, here, read this in the Apple documentation, or read this in the Android documentation about how to do it. So there's lots of different ways, that can be attacked. So I'm going to dig into this a little bit more. Now, each of these 5 areas I'm going to go through have this set of boxes as well. And again, I'm doing the highlight reel, not the half-day training here. So best practices for secure coding, that's for the dev side of the house. And then the best practices for testing is for the testing side of the house, right? So the number 1 piece of advice is don't collect it, don't store it, ever. There is no reason to store almost anything on the device. Assume the device will be reversed, breached, your data will be disassembled, decompiled, and found, right? And developers love to harvest data. Oh, I'm going to collect some of this and some of this and some of this and some of this, and I'm going to write it off to a log and so on and so forth. And so that's the biggest offender. There's a lot of stuff stored unencrypted, or permissions on the file are set to be anything on the device can get access to the file, which is also pretty bad. Android a few years ago, 3-4 years ago, came up with scoped storage. So Android scoped storage binds the application to any of its file stores. And so it ties them together with a common key so you can't get at the files. And that's an easy thing. It's a binary test. Go look in the app. Does it say Android scoped storage, yes or no, basically? So if they set the flag to true, then the Android operating system is going to handle a lot of that security communication and bindings between the app and the files. The other place we find a ton, especially recently, is IP or other sensitive data in the actual query strings. Here's what happens. They'll use the mobile app. They'll monitor the network connections. They'll see the query strings, and then they'll use them to brute force the back end on a real machine, not a mobile app, right? So be careful on query string construct. So testing for credentials, obviously, right? Look in the log files as well. We find a lot there. If you're used to using your device, if you do that swipe between apps, you'll notice that, an app moves in the background and one moves in the foreground. Well, that data is live. The data is live in memory when you do the swiping across apps, right? So you get an event queue from the device that can tell you your app's moved into the background. You should clean up your memory and your screen as well. If you use like a banking app, you'll notice when you put it in the background, the screen will switch over to their logo or some blank oriented thing. That's because they're protecting you. So there's tooling that can be used to find what's in that background. You don't want to have that kind of happen. Crypto is another train wreck. I'm going to handle crypto some more in a few minutes. And then the other thing is really, if you want to protect yourself, make sure the device has its own device password, right? Because that prevents bad guys from finding a device and getting into it. So there are easy API calls on iOS and Android to make sure that the device has a password and the app won't load without it, or the app will give an error message that way. So network's number 2, and you're going to find it's very close because it's 48%, right? So, and we'll take a look at network issues here in just a second, right? And if you think about most application developers, if they're building a web app, the infrastructure with SSL and two-way TLS and so forth is taking care of a lot of the comms. On a mobile app, they have to write it themselves and talk to an endpoint in the back end. And so that's where you wind up finding lots of issues. So as I mentioned earlier, third-party libraries can be guilty of this. We were working with a particular very large organization that has tens of millions of users of their portfolio of apps. We discovered that they were using a third-party library that was harvesting a little bit of PII. So it was harvesting the device MAC address and their geolocation and collecting that data, which was a nuisance. Shouldn't be doing that, right? And oh, by the way, they were transmitting it over HTTP, which meant if somebody knew how to intercept that, they were now collapsing a lot of information. That's likely what a nation state would use to monitor users at wide scale. So there's things out there, right? Don't assume a VPN is in place. So make sure there's security across the line. So in terms of working with developers, a lot of it has to do with, if you're really an L2+R, you should be using cert pinning. If you're not, you don't have to. And cert pinning is generally a bit of an education for developers to learn how to encode an application the right way using Apple Trust Kit or something else. And then you have to understand how to test it. The other thing is when you test cert pinning, test it with invalid certs, self-signed certs, other kinds of certs. The bad guys know how to do that in brute force, and they will find a way through if the cert pinning wasn't implemented correctly. So it's not just that it exists, that it was done right. The really good news is that 6 years ago, Apple came up with ATS, which is App Transport Security. You will find that some 70–80% of iOS apps disable app transport security and write their own network communication protocols. If you use ATS, that will give you a secure tunnel by default. And so we encourage people to look for that. It's another binary item you can find. It's either on or it's off within the environment. Now, if it's off, that means they have to make their own compensating controls and build their own secure network connection. Android has Android Network Security configuration. That came out 3 years ago. I keep losing years with COVID, so I'm going to say 3 years ago. And that's sort of a similar thing and helps you lock down the network connection as well. Again, we find a number of organizations don't do that. So the other really important thing that we find in working with clients is show a developer what a man-in-the-middle attack actually looks like on an insecure connection. 99% of them will learn from that and never let it happen again. They don't understand what that is. If you say, oh, this could be man in the middle or intercepted, they don't understand it. Showing it with their own code or one of the Crack Me apps from the OWASP project can really be revealing. That's one of our top behavior changers we have found. And then obviously you're looking for ATS and NSC when you check it. Look at the third-party libraries. They're another place where your data may be being transmitted somewhere to a third-party service in an insecure way. It could be the developer didn't configure it correctly, or it could be that their library doesn't work properly. Some libraries you will actually need to turn on a secure connection and tell it to use HTTPS or TLS tunnel or what have you. Third one is auth. The good news with auth, because I always want to have in the middle something happy, the happy news is that most apps are good at authentication. which is a good thing as well. So it's one of our lower ones. It's always kind of a fun surprise to tell people about it. That means that doesn't mean there aren't problems with it, but there's some really good documentation from Apple and Google, and we're excited to see that most folks do this the right way. And so as a focal point, if you think about the rate of code changes in your app, rarely does a team change your authentication. So once you've got it well tested and hardened, a lot of what we advise clients to do is just pay attention. Is the code changing or not? Are there flags in your system? Can you set up flags and controls in your system so that you and security get an alert when anybody changes a lick of code, anything related to authentication or crypto? So there's a bunch of things around doing it properly in terms of discarding from memory, discarding from the background, and so on and so forth. And then the other thing you want to do is you make sure you have expiration, right? So, 3 times, 5 times, 10 times, boom, you can't let them test again. They have to go through a different cycle to reset their password and some things like that. We find some apps leave themselves open to brute force attacks because they put no limiting on their authentication cycle as well. All right, so insecure coding practices. Take a quick look at where I am here. So this is kind of your gamut of developers love to put extra stuff in their app. They love to collect extra things. They forget things like hard-coded URLs and secrets and all that other good stuff. So, and you can see 47%, which is only 1 percentage point less than the network side of the house. Obviously, there's going to be logic flows in it. We're finding more and more these are coming from third-party libraries, and it's not necessarily that the libraries are malicious. They just weren't well-coded, right? And so the developer doesn't necessarily know how to judge the quality of a library they choose. They're looking for expediency or what have you. And that's why, again, everybody's looking at supply chain right now. So we also find a lot of extra debug features in there. Our 2 or 3 debug flag oriented automated tests trigger a lot just because it's there. Maybe somebody didn't set the build correctly, so that when the build is run, lots of debug is still left in there because they're used to using it in a QA process. Again, some of those things are just on the control side that you can do better. But that's what the bad guys look for. They're looking for debug everywhere because that's a really great way for them to hook into the app and find their way through it. So the biggest thing for insecure coding is bad crypto. So, and it's in spades. In fact, in our automated testing platform, we've expanded from half a dozen to over 20 different crypto detection issues, plus bad third-party libraries that are numerous related to it. So use of static values, I mean, come on, folks. Short key lengths, come on, folks. A lot of this stuff is like fixed in 5 minutes if they know how to do it the right way. And cert is another issue. So they might be using certificate and certificate pinning, but they're not using it correctly. And so you need to check that it's actually being done well. Also test for error conditions. We found oftentimes to aid the development and QA process, they have very verbose logging. Well, you know what? Bad guy's going to go create error conditions and go look at the logs and see what might be left in there. And we find a lot of forensic data buried in those log files, especially from the error condition side of the house. And, I think at every conference and every conversation I have, everybody says, look at the third parties. They really are the bane of your existence. So anti-tampering. So this is interesting. So obviously there are things that you have that are defenses in your web perimeter and your network perimeter. When you get to the mobile device, you start with the fact that, okay, so bad guys, bad actors, nation states, they're going to have devices that are instrumented, jailbroken and rooted in a way that they can instrument an application, sniff at everything, memory probes, the whole 9 yards. There's even kits you can buy that have, like probes in the semiconductors and things like that to really do it in a deep way. And so we find about 1/3 of apps are exposable to reverse engineering in a bad way. Now, if you presume, and you work with your architects and your developers, and you presume that your app is going to be reversed, let that guide how you design and build the app. We had someone come to us that said, "We want you to pen test the app because we keep getting these coupons coming through to buy things. And we can't figure out where they're coming from." So we get in there and we reverse the app in like 10 minutes. One of our pen testers found that the actual method for generating the coupon code was in their app. It wasn't on the server side. It was in the app, right? So in Guys had reversed it, dumped on the dark web. Here's the code generating IP. No one else ever had to breach the app because once you had the method, you could just publish the method, right? And people could go generate their codes. So that's an example of smart architecture, right? It has nothing to do with actual testing. It has to do with, did you do the right thing? Anything that's sensitive should be stored and generated on the back end. Now, developers will say, oh, for user experience and network latency, and it's going to cost me 10 more milliseconds to do another round trip or whatever else. Everybody's got pretty good bandwidth, right? If you're really designing an online, offline app, then think very carefully about what your offline experience really needs to be from that perspective. And again, developers are trying to create a great experience for the user, so there's balances in there in the architectural strategy you might want to do. So our number one tip for resiliency is actually a smart architecture, right? From that perspective. What sensitive data are you transmitting, storing, capturing? What key management might be necessary? What crypto is appropriate? And so on and so forth. And making sure you do as much work on the server side. Now, I keep talking about reversing. So the better tools out there are Frida and Radari, and there's a link to the repo as well. They are advanced tools, so you'll need some training or have your own advanced skills in order to use them. But even anti-tamper, we can get around, a sophisticated user of Radari can get around most anti-tampering commercial tools you can buy using it if they're really smart and know what they're doing. So, however, that doesn't mean don't use third-party obfuscation tools. Using third-party obfuscation tools helps protect you from the non-nation state actors. Right? So they're the ones that are going to help you from the semi-amateur to mid-level amateur. When you think about the bad guys, it's all about, they're going to go where the money is. If it's really hard and they've got stuff to look for signatures of the anti-tampering, and if they see certain things, they're just going to be like, unless there's a high likelihood of a payload here, I'm not going to go fight my way through it. Even though I said I could reverse it with Radari, it could still take me weeks to do it, right? Much like you would talk about, take a cray to crack a piece of crypto. So, on Android, there's a cool API that came out in 19 called SafetyNet. That SafetyNet actually checks for the integrity of the device. So is the device rooted? Does the device have certain probes on it? Google's actually tracking the tooling out there and looking for tooling signatures, even all the way down to potential tampering of the silicon in the device and proper use of things like TEE. So SafetyNet is a good API. Again, that's one of those things you can just look for it in the code. Is it on or off, right? And then when it's on, you pick up a lot of free stuff. And then you should, as a pen tester, if you're worried about this and resiliency matters, you should jailbreak or root the device and test it for resiliency. The reality is there isn't just a single API call that protects everything. So on iOS, for example, for a jailbroken device, there's multiple different techniques that the developers are going to need to apply to try to get around the tooling that the bad guys or the good guys are going to try to use. Also watch out for string tables and methods. Those are other places where you can hook in and find information as well. And depending on how those are structured, you can make it a lot harder for the bad guy to get in there. So the thing that cracks me up the most is when we talk to a client, they're like, oh, we're not worried about security bugs. We've got anti-tampering in place. Yeah, right. So we were with a trading company and showed them a man-in-the-middle attack. And they're like, oh, yeah, we just bought XYZ obfuscation tool. That's going to protect us. And we're sitting there. So we said, OK. So we left. We asked for a meeting again a week later. We went back. And so we took their app. We inserted that anti-tampering stuff and showed how we could do the same thing all over again. We actually work with some of the anti-tampering guys who actually use us in a validation cycle to show that we test the app, then they put the tampering in. We test the app again to show that their anti-tampering doesn't create new vulnerabilities, right? But it also shows it doesn't fix any of them, right? So if your app has 5 vulns in it, you go obfuscate it and we test it again, we're still going to find the 5. I don't think we've ever not found the same 5. Right. So from that perspective, the anti-tampering can make it harder to reverse, put friction in the machine, but it doesn't replace the good hygiene parts of what you really should be doing in the mobile app. So that's the 5, right? So hopefully you're not terrified to use your device or any of the apps on it. But, the reality is just like websites, some are better than others. It's a really interesting and lucrative place. If you talk to pen testing companies, mobile pen testers typically make 25 to 40% more money than other kinds of pen testers, especially if you develop IoT skills. So from a career perspective, it's a great place to go. By the way, we're hiring. I have got 14 pen testing, 12 to 14 pen testing slots open right now. We have more business than we know what to do with from that perspective. But the reality is that we're going out and training everywhere we can, including in colleges now, to try to get some people to come into this space and have fun with it. Now, if you think about the test program that you have, answer yourself this question. Do your developers write testable code? Do your developers write their own test cases? Well, if your developers write their own test cases, they probably write testable code. And if they don't, they probably don't. Now, let me explain what a little bit of that means. So the first thing is a toolkit. So if you're going to go the homegrown world, here's what we typically find. So you got the OWASP tools. The MSTG hacking playground is great. There's lots and lots of tooling in there. There's Frida and Radari that I talked about earlier. Most people want some sort of network tool. So Burp or Zetattack or what have you. And then you will need jailbroken and rooted devices. You can't do this without those. Rooting is easy on just about anything. Jailbreak is hard. Cydia and one or two other jailbreaks are out there. Apple's getting better and better at making it harder and harder to jailbreak a device. We do have tooling that can test a lot of things without a jailbreak. So it's jailed testing in our automated tools. But that's something to factor in out there. The iPhone in your hand, you probably can't use. You're probably gonna have to go buy an older iPhone device that's still got an older OS on it. And there's a kind of a gray market for those that you can find. Now, from an automation perspective, there's some free tools out there to do automated SBOMs. I'm going to show you. There's free tools that do an automated analysis. If you look at something like MASVS, that's also a free tool out there. MASVS, if I benchmark a MASVS report against one of my people or one of my tools, it will blow your mind. MASVS generates a ton of false positives and misses a lot, and that's the nature of a free open source tool trying to be a commercial tool. But it's out there. And then we have a toolkit for pen testers, and we have an automated platform that plugs into your DevSecOps pipeline. It scans your code all the time, right? And runs autonomously in the background. So, and it's got all the SAST, AST, IAST, API sec, Cyclone DX, and all that other fun stuff in it. So that can be the toolkit. Now, the single biggest thing that we find that's related to testing efficiency is the testability of an application in and of itself. So when you're writing a web app and you're testing a web app, if you're using any of the test automation tools in the web app, there's a set of standards that you're looking for, right? How am I hooking a control name and things like that. In mobile, it's a little more of the Wild West. So there's commercial UI, UX, and functional testing vendors, guys like Perfecto, for example, and SmartBear and things like that. And they can do UX navigation, and they can automate a lot of that with like record playback, or you can write scripts in order to make that happen. Well, for security testing, some of that you need to do as well. Like, how am I actually going to test the authentication of my app and do it in a way that I can test it every day and break the build, for example? And so the testability of an app really has to do with how the app is designed so that the test automation tools can do the work for you. Now, if you're doing manual pen testing, it's just as beneficial, but the automation is got a lot more value to it from that perspective. And so what we find is organizations where the security team works with the architecture and development and design teams to design in for testability, they can move to a world where automated testing can cover 60 to 100% of what they need. And then the manual testing is the edge cases and the more complicated things. And the analysts shift into more of an advisory role on the development side rather than the hands-on keyboard all the time. So if you need speed, tell your developers that's how to get security out of the way. Write a testable app that I can automate the testing on. Right? Now, what gets in the way? CAPTCHA. So I've got an automation engine that can navigate an application, but I can't bypass CAPTCHA. No functional testing vendor, no UX testing vendor in the world can bypass CAPTCHA. If I did, I'd be a trillionaire if I had that product, right? Imagine who I could sell that to. Multi-factor authentication. Can't bypass that either. Does that mean I can't test it? No, that means give me a build with those disabled, or give me a path to do something when my automation hits that part of the app so I can get past it and automate everything else behind it, right? Anti-tampering. Install anti-tampering after QA, not before. A lot of developers want to put it in the repo and have it be in the build. Well, anti-tampering gets in the way of your functional testing and your security testing, right? So do that after you've certified that the app is there. And then inconsistent object labeling. So the way most automation tools navigate the UX is actually through labels that they can either see at an API level or on the screen level. And when that's inconsistent throughout the app, it doesn't work. You know how to make them consistent? Accessibility controls. If your development team follows the Apple and Google guidelines to use accessibility controls, which allows the phone to like read things to the user and stuff like that. All of the automation vendors hook into those. And so your functional testing, your QA buddies, along with your security teams, get a much better automatability, a much higher percentage of automation just by making sure they use the accessibility controls. There are design requirements to it, there are coding requirements to it, but that actually makes your QA team and your security team a lot more proactive and productive from this perspective. We have customers that automate 90 to 95% of their security testing. The other 5% is still the human pen testing part. And yes, they have governance rules where they have to have third-party pen tests for certain things and things like that. But that's their functional UI UX testing and their security testing. They're able to do it because they've got the right strategies in place and agreements with the development team about basically writing testable code. And I think you're going to hear more and more of that because as people are trying to move faster and faster, you need to automate as much as you can, and that gets into testability. Now, I'm going to veer off into two parallel areas here that are really useful. And we're working with a number of other organizations, including Jeff and Contrast and others, on a spec called Cyclone DX. So Cyclone DX was its own project that merged into OWASP. And Cyclone DX is basically a standard way to produce an SBOM with a standard vocabulary for that SBOM. Cyclone DX was launched publicly this spring. Steve Spriggett and Patrick Dwyer are the drivers of it. If you don't know Steve runs AppSec for a small company called ServiceNow. And he's been around the world for a long time. He's worked on other specs. And so it's a great project to get involved in. You know, if you're in the session this morning with Jeff talking about software labeling, SBOMs are kind of a precursor to that. SBOMs are also really important for your supply chain risks. And one of the things we have as an industry right now that's a problem is there's no standardization for what is an SBOM and how do I compare two different ones to each other and what information should it include and yada, yada, yada. And that's basically what Cyclone DX is doing. Something like 40 or 50 vendors have signed up and their products are producing SBOM using the Cyclone DX as a standard output option, myself included. There's also a really cool tool, which is the dependency track. So at the OWASP 20th, if you were online when Steve presented, he rolled out the dependency track tool. So it's an open source tool that you can use that will allow you to take any Cyclone DX SBOM and merge them together to get more aggregate analytics. One of the really cool things one of our customers did with it was they actually looked at the entire chain. So they had tools that were testing the cloud, tools that were testing the back end, and then our stuff testing the front end, and they pulled it into the dependencytrack.org and merge the SBOMs from the front end and the back end all together to get a holistic view of their entire infrastructure, right? So that's been a really cool tool. The other thing you can do is you could take your entire portfolio of applications and load them into the dependency tracker, and you get a dashboard that's like, what's the current state? Within that, you'll find patterns like, here are the teams that are using these bad libraries over here, and guess what? They all happen to be in Australia or something, right? You know, so you can find stuff like that in there. So take advantage of it. If you want to see, if you're on a mobile team or if your company has a mobile one, you can submit it and we'll generate one for you. So if you come to the SBOM location, and I think this is going to wind up getting posted into the OWASP Cyclone DX project, but it's basically a starting point to give people, it doesn't list the vulns, it just lists what's in the bill of materials. It does, however, peek down here, it does actually do a SAST and DAS scan, so it tells you if there are vulns in it, not what they are. So it's a little leading indicator for you. Now, I talked earlier about mobile apps are talking more and more to things. And so when we think about the mobile apps to things, that's another vector that becomes very important. About a third of our customers, 20–30% of our customers are using us with a thing testing scenario. So that's basically mobile apps talking to a thing or a BLE, Wi-Fi, what have you. And so a couple of years ago, a group you may or may not have ever heard of called IOXT got started. And IOXT was trying to conquer the certification for my things side of the house. So Amazon and the Ring team, for example, is in there. Facebook, Google, pretty much everybody except Apple's in it. And there are literally thousands of IoT manufacturers that are involved in it and use it as a mechanism for testing things. And so whether or not you've noticed, things have actually gotten more secure from all the vendors that are part of the community and using the certification. A lot of the issues with things now are like reusable passwords and not changing passwords and some stuff like that, but a lot of the underlying infrastructure is getting better. So what the organization realized was need to do something about these mobile apps that are talking to these things. So let's go create a mobile app spec and certification program for it. And so they called us up and said, you guys know what you're doing. And we'd already done a ton of work with Google and Amazon and others. And we started looking at it. And after about the third or fourth meeting, it was like, wait a minute, MASVS is over here. Why don't we just use that? Now, when you think about MASVS and the OWASP projects, they're all frameworks. They're not certification regimes. But what if you took MASVS, did an intersection with IoT things and the characteristics of those, and actually created a certification standard to go with it? And that's what was born. So we work with a bunch of other folks in order to create this. It was also launched this spring. And the idea was, the mission was to create a reasonable, reliable industry standard way to build, test, and certify the security of mobile apps that connect to or through things, right? And interestingly enough, VPNs are often appliances, so they got to be called things, which means we're also testing a lot of VPNs as part of this as well. I should release our VPN benchmark. It would probably not blow your mind, but most people, other people would be blown. So, so we took the MASVS, we went into a dark room, and 60 days later popped out the IOXT certification spec. Now, we didn't take the whole MVS and say, you have to do everything. We actually created an organized structure that said, these are the things that are relevant, these are the things that are most important, and created a certification regime out of it. Organized it into eight categories. There are some additional things in there, like expiration and versioning, that's not in the traditional OWASP-oriented spec, and things of that nature. So you can actually make an attestation that this certification is only good up until this date, or only good through this build version, or something to that effect. And so it basically naturally expires, or if dependencies expire, and so on and so forth. Also added some minimum requirements, which basically it's got a level 1 through 3, so you kind of have a low, medium, high. So now you can do a grading thing, right? So I might choose to be low or medium or high, and depending on what my thing is, like all the healthcare ones are mostly high, as you can imagine. But there's other stuff like your doorbell, low might be good enough for that, depending on what the thing actually does. And so much like the MASVS and MSTG, we created a profile. That guy over there is something like 27 pages. And then there's a test library. And it's really great because almost every section you go into, there's a footnote that says, link to OWASP, or link to OWASP, or to learn more about this thing, go back to the OWASP, MASVS, or an MSTG as a resource. So if you're in web, but some IoT stuff, and you want to learn about the IoT side, there's a lot of good learning resources from IOXT. But they're not like OWASP with all of the sort of free world. It's much more a vendor-driven common certification. But it's a really cool way to say, how do I take an OWASP project and create a new thing out of it? It's also an interesting exploration into how do you take an OWASP-like framework and turn it into a certification regime from that perspective. So I've talked a lot, and I always talk a lot. So mobile is cool. Please come join us on the mobile journey, whether you work for us or somewhere else. Please help us raise the bar. If you're looking for a place to get a raise, it's a nice place to go. If you're not already there. Threat modeling is still the center of all universes. Training is still the center of all of this. And you can crack the bigger nut by looking at the 5 key areas, really the 4 key areas, and I give you a throwaway on the authentication one, to have a look, and please participate in the project. So wrapping up the resources. So academy.nowsecure.com, what I just showed you, there's multiple courses in there that blow all that stuff out into details. We actually have Now Secure Connect, which is an annual virtual event that has live and recorded training in it as well. You're welcome to come join us. It won't cost you anything. You'd have to sign up because I have to validate your email address. But come and enjoy that. We got some really, really cool people. Jeff and Steve Spriggett and Elaine Fairman from CISA, the federal agency CISA, they're all doing a session on SBOM and labeling, which is going to be really cool. We just recorded that. We also have a panel of CISOs and retired CISOs, and it's about how to convince me to care about AppSec, which is also going to be really interesting. So, doing a 2-day conference, you don't get a lot of CISOs to sit at something for 2 days, but we came up with something that was interesting. And the members were asking us, our community members were saying, hey, could you help us convince our boss to care? So we basically created a Convince Our Boss to Care panel, which should be kind of fun. So get your free SBOM. You can also, if you are a registered employee with your email domain that matches your company name, that also matches the email domain on the developer of the mobile app for your company, we will give you a free report, which is actually exposes all the fun data that I was talking about earlier. We obviously have to be careful that we don't accidentally do an RD on somebody, because a bad guy gets a hold of one of our reports. So we do some attestation. It's not just a free scan and shoot type of thing. But we're not a big responsible disclosure business. You won't see us doing it very much because we're more on the other side of trying to make sure everybody's safe and protected. So thank you for your time today. I have stickers if you want some. And my email address is there. You can find me on LinkedIn as well. I spend about half my time working strategy and in the field, and the other half of the time trying to figure out how to grow our company. And so, as you can tell, I love the mobile space and love to have you join us. So, any questions? Did I just melt your mind and you're ready for lunch? It's all good. It's all good.